Well, now I want you to go ahead and see if you can actually practice calculating the derivative of a specific function. So here I have a function f of x laid out. It's actually just a fairly simple quadratic function, and I'm curious if you can go and try to compute f prime of x on your own. So I'm going to ask you right now to see if you can pause the video and write out all the detail, kind of like what we did up above in example number 1. And when you unpause the video, you'll see me working through the solution. Okay, well hopefully you went ahead and actually tried to compute this. Let's see how we would do this. We would note that if I wanted to compute f prime of x, I have to start by setting up again a limit as h goes to 0, and I need to compute f of x plus h minus f of x over h, as that is a nice slope formula. So now I'm going to go ahead and do a simplification to the numerator by kind of filling in what f of x plus h is. So notice here I'm going to get 1/2 times an x plus h all squared. I'm replacing x with x plus h. And then I'm going to get minus 5 times x plus h and a plus pi. So that's just my first portion. Now I'm going to have just f of x, and I'm going to make sure I'm putting this in brackets so I can successfully distribute that negative sign in a moment. All right, so here's what I have, and now I'm going to simplify some more stuff down. In the numerator, I'm going to end up with here a 1/2 times the quantity of x squared plus 2xh plus h squared. Then I'm going to have minus 5x and minus 5h plus pi. When I distribute my negative into the second quantity, I'm going to get minus 1/2 x squared plus a 5x and minus a pi. Now, of course, right away from this, I can start to see that there's going to be a lot of things that are going to start to cancel out right away. I have this minus pi and plus pi. I have a positive 5x and a minus 5x. I can even kind of look ahead to see that when I distribute my 1/2, I'm going to get a positive x 1/2 x squared, and I have a negative 1/2 x squared over here. In total, it looks like I'm going to end up with only the following pieces remaining in that numerator. I'm going to have, with the 1/2 distributed, xh plus a 1/2 h squared minus a 5h. All this, of course, divided by h. Now, conveniently, everything here has an h in common, so I can go ahead and I can factor an h from the numerator. That would leave me with x plus a 1/2 h minus 5. With all of this being over h, I can cancel out an h from the top and the bottom, and now I can just focus on doing the limit of the stuff that's left. I've removed this h problem that used to be in the denominator, and now I can just focus here. Now, since, again, I have a nice polynomial, and h is the only variable that this limit is controlling, if I substitute in 0 for h, I'm going to end up with just x minus 5. So I should end up with that the derivative of my function here is x minus 5. And remember that this formula is good for finding slopes of tangent lines on this graph. So hopefully you were able to get to the same spot. If not, hopefully you were able to kind of catch maybe where you made a specific error. If you're looking to check these answers again on your own, you can go ahead and rewatch anything that I did here in the video, or of course the full solutions are posted up online in Blackboard.